get on to more normal things in life. Well, thanks everyone for taking time. I know life is crazy in some places right now, so it's good to see you all. Good to see everyone's doing okay. One quick update. I did hear both from Max and from Ren briefly today. So Ren is on a flight to Taipei and then to Toronto from there. So hopefully we'll hear tomorrow that she's back in Canada. So yeah, but an update on the GWB side of things.
Mm-hmm. That's
Cool.
great.
Okay. Yeah. Um, yeah. Well, let's then maybe hear from other folks. Devin, I see you first on my screen. Would you begin to start us off?
Sure. So I guess an update on the GWB is that it seems like things are running quite smoothly with regards to collecting data. And I finished off, I guess the first 3 case histories are done, pending a final review. And it seems like there are a couple of people that are, or a few people that have shown some kind of leadership qualities over there. Latata, and I think Doug mentioned one other. So they seem like they're able to sort of do everything and teach others. And so I've made them administrators of the Facebook group. And I got, I posted an update for them to update their SimPEG and to download the latest notebooks. So now that that's finalized, and I was able to get that to Ren before they left, so I think they'll be able to do this. Yeah, and I also have just been trying out that functionality, and I like the new notebooks. The tree mesh seems to work quite well, and it runs very, very fast. So all the upgrades that you've been doing lets me, work with, say, 3,000 to 6,000 cells and get a lot out of it. So that's been quite nice. So that's sort of the update on GWB. And then, yeah, looking at adding some more of the tutorials. So we've got frequency domain EM and time domain tutorials just for forward modeling that are going to get added. I've got a SIL mesh and a octree mesh for each, and they run quite quickly. And one of the things for the time domain that I focused on was just a very good explanation about time stepping and defining waveforms. Yeah, I remember somebody mentioned that this was a troublesome thing for certain people. So I'm trying to finalize those. And
one other quick question about sort of things to highlight too is boundary conditions. Is that something that you put a bit of emphasis on?
I didn't talk really anything about boundary conditions. Are you talking more about some assistance in mesh design?
Yeah, so just with respect to like including sufficient padding.
Yeah, I've thought about how far I want to go down the rabbit hole there, because I guess for these I'm trying to show how you would set up the problem, and I'm trying to stay away from too much text, because as it is, it's fairly highly commented.
Yeah, this one though I think is important. I've seen a number of folks trip up here. Is that so? And I don't think it should take up too much, right? Is that for frequency domain we need to be worried about skin depth. For time domain, it's the diffusion distance, and usually rule of thumb is a factor of 2. Is going to be enough. But I've seen a lot of examples where people assume that a single diffusion distance or a single skin depth is far enough, and it's not.
Yeah, it's not.
In most cases. So just like I think a quick comment on both of those could hopefully prevent a lot of headache in the future.
Yeah, okay, that works. So yeah, I'm basically just trying to finalize those and then build the website locally, and just start accumulating some more of those examples. I was kind of hoping for suggestions on how I'd like to approach getting an inversion example for frequency domain EM and time domain EM that's not going to be computationally impossible.
I guess we tried and played around with this, and I'd be super curious to hear what other people think. I would, in some senses, be tempted to do one like SILMesh one that is going to be pretty quick, and then one 3D one that's maybe pretty minimal, but still gonna potentially have to chunk away a bit. Like I think if you can shoot for under 10 minutes, that's tolerable for a 3D inversion. And I mean, keeping it like simple so that, you know, block in a half space or a layered space or whatever with a couple of frequencies. I mean, there's one example that we do a loop EM system that's a couple of frequencies. It'll be easier actually if you do, so for the 3D case, if you want to do like a single large loop just with multiple data inside that, because if we just do a single transmitter, it's less solves. So that's a couple things. I don't know if other people, Soggy, if you have thoughts on, if you're speaking, you're muted. Yeah.
That's what I would do. And then try use octree mesh, so that'll save some time. Yeah, so try use frequency domain. That's probably better at the moment. Time domain is a bit slow.
Yeah, well, it's also quite. Yeah, time domain ones are a little bit more challenging. Yeah,
Yes.
I don't know. I at least working with the Fortran codes, I hadn't really had as much success doing large loop as I did having source term, like source receiver pairs and moving them around. I know that's a lot of right-hand sides, but I was getting better results with that code.
For sure. I mean, you get more excitation directions and things like that. But if you start with just a very simple model, is like, let's just do a layered Earth, or even, Sagi, we did like a large loop with multiple receivers for the seawater example, right?
Yeah, we did the 2 loops and the multiple receivers, and the result was quite good at that point. It was a long time ago, like several years ago. But I think, yeah, we can revive that. But it one run like in 10 minutes, so it'll take like several hours.
Yeah, I mean, we can always just make it clear that you know, this is just showing you like the steps and what you would get out, but don't be interpreting the model that comes out of this. You just use 4,000 cells or something really easy. You invert it, you get something, it wants to put something kind of in the right place, and you just say, you need to discretize more, but this is how you would do it. This is a script for doing it.
Can we just promote the 1D code?
Yeah, I mean,
because the Stitch 1D is fast. It's really good. I mean, I'm working on a synthetic right now, and it's quite amazing how well you can recover a compact conductor even with the Stitch 1D code. And it's going to be fast, right?
And that 1D simulation is in the base simulation branch, or are you working off on your own little universe right now?
It would be a dependency on SimPEG EM 1D, but we can just pull it as a requirement. It's not it's all SimPEG, right?
Yeah. Potentially we can just merge that in the near future, because I mean there's nothing like really blocking that, because like I was lazy, and then it was quite different at that point, because I mean it's quite different from the current time domain code, how it sets up, and we don't really need to worry about the boundaries here and stuff. So but as more people are using, there's no reason why I need to put it in a separate branch. So yeah, we can.
And the hurdle too right now, being it's on its own, is that if you do a pip install SimPEG EM1D, it tries to pip install SimPEG, and then we don't get all the Anaconda benefits, right? With the compiler and everything.
Yeah. So one bottleneck in the 1D code is the Fortran dependency. So
that's taken care of by SciPy. No, SciPy has a Fortran compiler.
Okay.
So we don't have to worry about that. Yeah.
Okay.
And that's one where I'm sure we could get a bit of support from the Honda Forge team. They're pretty awesome with helping out.
But we don't even need it. As long as SciPy is installed, it takes care of it.
But you still need to compile the Fortran code that's shipped with.
No.
Yes.
Well, I mean, when you do a pip install, if SciPy is in your environment, it compiles it for you.
Really?
Okay. But that's still something that we then have to include, I believe, in the Conda recipe. Although if it's working through pip, then the pip, like the thing that we do to build a Conda recipe from pip, should take care of it.
Yeah, because I recently installed on Clara's machine, which you use in Windows. So Clara is here in Stanford.
Yeah.
But yeah, we had to follow the same instruction that you made them at one point, using this Visual Studios and stuff.
I'm shocked because I just installed my new machine and I didn't do anything.
Okay, so the pip install actually worked.
But no, but that's the thing, is that you want to Conda install SimPEG, right? So we'll compile the C++, and then after this, all you need to do is just grab the files, the SimPEG EM1D, and then path it, and then you're ready to roll.
Okay.
Conda has a G4Tran installer as part of it.
Yeah.
So maybe a trajectory there actually is, can we first, before trying to merge it into SimPEG, can we first just try and get SimPEG EM1D up on Conda Forge and just like work out the kinks for that installation process on that repository and then merge it in?
Okay, sounds good.
I haven't looked at the code with the Fortran code yet, but how involved is it? Translate it to C pretty quickly and not worry about it.
Joe, can you repeat that?
If it's not too much, I can just translate it to C pretty quickly and then write some quick Python wrappers for it.
Well, that'll be awesome, Joe.
It's an issue of Fortran versus something else.
It's the MPy mod, right? That calls Fortran.
No, it's not. So
didn't Leon write some Fortran and put some Fortran code into it? Basically, is that where it came from?
No. It's so it's a long story short. So when I developed the 1D code, somebody in USGS was interested in using it, and that was a bit slow. So I think he kind of translated some of my Python code into Fortran code, and then that made up quite a bit of a speed up. So that's actually the core part of the code. So yeah, it'll be great to rewrite that in either C or whatever language that works, and make it easy to install. Okay. Anyway, so yeah, so Lindsay, I like the idea. So we could do a couple other things that we can kind of use the latest simulation branch, and then update the namespace and stuff, and then deploy on Conda Forge, and then we can merge that maybe to a simulation branch.
That would be great.
Okay, sounds good. I'll work on that.
So I think that was mostly it for me. I was going to talk about some MT stuff, but John's not here. I took a short look at some of the stuff he's been working on, but didn't really go in too deep.
Excellent. Well, Savi, would you like to anything else?
Nothing particular. I applied for Google credit.
Oh yeah.
So yeah, I just wrote like a simple proposal. Oh, I want to do a 3D inversions and large computation power. So I got $1,000 credit. So I'm looking forward to play with it. So I think they got some free, I think a $200 credit that you can just get it, but there are a lot of limitations. So you can use like 3 cores or something like that. So I mean that's not that useful, which I thought. But we'll see what I can do with this $1,000. Okay. Yeah, nothing really particular. I got an email from one of Rachel's students in University of Calgary. So they are developing some of the fluid and coupled flow code, and he seems interested in using SimPEG to develop. So I had a quick chat with him and explaining just like how to set the boundary conditions. So Yeah, it might be a like interesting avenue. So we kind of established some of the geophysical problem and one fluid flow problem, but having a little bit like different problems into a SimPEG.
Yeah.
That'll be an interesting avenue. And I think the fluid problem, although there are a lot of like a good commercials or open source code, it might be nice to have some in SimPEG. Some are compatible with like ML flow. And yeah, so that's sort of where I'm going, and I'm looking forward to see that happening.
Excellent. Well, feel free to invite them to the meetings. It'd be great.
Yeah. I'll do that. Like he's in the very like a starting stage, just learning Python and learning mesh class. So once he have established something, I'll invite him.
Excellent.
That's it.
Tom.
My thesis was on,
Oh, Joe. Who's talking?
I was just saying, like, my thesis was on, a couple of fluid flow inversions. So if you need some help with that too, the fluid flow stuff.
Oh, it looks like
Joe,
we
it
went
was bit.
yeah, we're lagging here, right?
Yeah, I turned off video.
I think it's Joe's internet, unfortunately. Oh, Joe, are you back?
It's probably my internet. Yeah, I'm here. What I was saying is I can definitely help with the fluid flow stuff as well, considering my thesis was kind of on that. So, yeah.
Excellent. Oh,
Yeah, on my side, I spent basically the past week writing GUIs for to be able to handle the SimPEG EM1D for time and frequency. This will be, it's kind of part of what we're pitching for the Python API. And so I ran tons of time domain and FEM in 1D. I can show you guys. I can share my screen if you guys want to see.
yeah, that would be great.
Which screeners do you see? This one?
See GeoAnalyst, and I see a notebook on the left.
All right, that's it. Yeah. So so basically, we're kind of trying to revamp. This is just a prototype, to be able to replace what GIF tools would basically do. To just be able to connect to the analyst project. So I have like frequency and time domain data simulated over like some geology here, and I use SimPEG for the forward simulation. So that's also pretty cool. I did a tiled approach with Octree, and it actually turns out to be. I mean, it's a simple model, but the fields are fairly smooth. So that's pretty cool. And after this is just inversion. Go ahead, man.
Did you use the 3D code that I provide you, or like a different what 3D code did you use?
Yeah, no. So I didn't manage to make it run. So I was getting some indexing problems with the SkyTime. It's just
okay.
I was already set up to run it, and I'm kind of time crunch,
Right.
and I didn't want to go back. So right now this is a VTEM. It's a VTEM system. But
got it.
It would be great if we can figure it out, because maybe with what Devin is preparing, it will enlighten me on how to run it. But time domain is super slow compared to the frequency. It's very slow. Anyway. And then yeah, look at this, man. Those are stitched 1D inversions, so just showing our own profile, and it's pretty impressive. This is a compact conductor, right? And look how well we're nailing it.
Oh, nice.
Even at depth, like we're even like picking up like the tip bit here. So, and this is fast, right? The stitch 1D, all those stations. This is like 10,000 stations. It takes like 5 minutes to run. So I think at this point, I'm not even gonna bother going to 3D. Like I think if your uncertainties are set well, You're not trying to push it too hard for like near edges. The Wendy code is really good. It's really strong code. So you got to be proud of that one.
So then how did you get rid of that sort of arcing that happens?
The arcing will happen if you start to really want to fit hard, like the shoulder here, right?
Okay.
Otherwise, like when you're right on top, like this is almost a Wendy experiment. Here, it's almost a Wendy experiment.
Yeah, I see that.
It really depends how much you're pushing your data.
Well, I guess so. You sort of setting the uncertainties at the shoulder of the anomaly to be fairly high so it doesn't fit, or
we can go through it later. Yeah, okay. I can show you. I just wrote I tried to figure out a way to be able to do it, automate it, so we don't have to think about it too much. But yeah, it works really well.
Great. Yeah, I mean, like it depends upon the scale that you're dealing with. So, I mean, usually airborne survey, like you're covering like hundreds of kilometers. So, in that scale, and if you think about the footprint of your system is very small, like maybe a couple 100 meters,
yeah,
or maximum a kilometer.
Yeah.
So, I mean, if you don't really care too much about like a couple 100 meter scale, using 1D is pretty effective. So 3D may not be really needed, but I mean, that kind of depends. So
if you have something
like
superconductor,
1D kind of,
sure.
Right, and then actually in that case, 3D doesn't work neither. So
right.
Anyway.
Yeah.
So I mean that in that case, plate modeling might be better. Anyway. So, but I think that there's still a value, like in a smaller scale, if you're dealing with like a couple kilometer scale using the airborne data, there's still a need in 3D code. But anyway, so.
Yeah, and I think it's mostly trying to fit the late time channels super tight. Then then you have the largest footprint. But if you only try to fit really well the early decades, it does a really good job even for compact object. That's it for me.
When you actually screw up, when you really screw up is when you got the topography. So if you got rough topography, like that's where you sort of screw up.
Oh yeah.
And the 1D assumption is really kind of break.
Right. And if you have conductive overburden for sure.
And Saki, where is the work that you did to speed up the 3D forward modeling? Is that on a public GitHub repo? Is that something we could start to sort of look and sort of translate ideas into SimPEG?
Yes, it's in the SimPEG research, and then it's like something real AM 2019 or something like that. So the basic idea is like do a tiled simulation. But so I found like a fast interpolation code for just a regular grid, and that was the main thing. And then when you're projecting your data, like rather than like handling the waveform, like because we're directly handling the waveform into the problem. So you discretize the waveform and put that in when you're time stepping. Rather than doing it, we can just compute the step off and then convolve it.
Yeah.
So I think there's a bit of benefit by doing so, because like then you can hard code time stepping, and so the user doesn't really need to worry about that. So you make sure like use pretty fine time discretization, and then it's actually fine because you're using the tiling. Your simulation is like your small problem, like a single problem is very small.
Yeah.
So it like having many time steps or many factorization doesn't really matter.
Yeah.
So yeah, in such a way, I think I could handle like, I don't know, a couple thousand or like a couple thousand transmitter pretty fast. And then you can parallelize it massively. So
nice, because that would be really nice. Because that would be really nice to think through, I think, as we look at like sort of higher level wrappers, or sort of what actually we want users to be interacting with, is if like we can use your ideas there to basically give, like if you're doing an airborne EM inversion and you want to use a 3D code, like this is the setup you should be doing, and have it be a bit more opinionated. Because yeah, right now it for sure is like much easier to just set up a 3D tensor mesh and design your own time stepping. Yeah, which is not necessarily the most efficient.
Yeah, I think at the end, like it's good to have a like a generic EM class, like FDM and TDM class. But for like a real application, we can fine tune certain things and have a small simulation class where they can basically easily run. That seems a better way to go.
Yeah. Cool. Joe, do you have any updates?
Yeah, I mean, just in the midst of trying to get everything settled and getting myself worked in up here and make sure everything's going well. I've been working on Azure pipeline stuff. Just mostly working with just my own. I forked SimPEG to my own repo and just kind of playing around with it inside there, just to see it testing and see stuff. It seems like it builds things a lot quicker than Travis does. The tests run quicker generally. I'm just trying to come up with a decent way to do a bunch of tests and figure out their stages and see if there's ways we can mess around with that. Mostly I've just been playing around with it. I can generally reproduce the functionality that we have with Travis right now on there, so that's good.
And it lets you test on multiple systems, right? Which is, we probably don't need that for SimPEG, but for discretized.
Testing on multiple systems is good. Like for SimPEG, we don't necessarily need it. Basically, but what we would do with SimPEG is testing on multiple versions. But with discretized, we'd like to test it on all 3 systems, just that it compiles properly. See, other than also, what else? Well, before all this kind of stuff happening, I was chatting with Andre Swedinsky about their field camp and like trying to push them to get their data open that they collect. They're only going to have about like 10 this year, but I don't know what's going to happen with that now.
Right. Well, if it does happen, that would be a valuable set of data to have and just to play around with.
That's what I was thinking. And it's like at this point, like they only had 10 students, so they were not going to be able to collect that much data compared to what they normally collect at a field camp. So I'm like, well, maybe this year would be a good year to get into that and making it all open source, because it technically should be open and anybody can request it if they want it. They're just not a good source for that to happen.
Is that something, Joe, that if we just had a way for them to upload data easily somewhere, do you think that they would just do that?
Possibly. I mean, I think they could. I mean, there's obviously I think it would be a little bit of licensing thinking. Sure. I know we were talking about some of the data licenses before with GWB stuff, and it would definitely be one of those things where it's like, okay, well, if you're using the data, you should at least cite that it came from field camp and know that it came from a field camp with students collecting data. But it's definitely a useful thing to have out there just for people to play with other data. So that could be something that we should probably just make it. Could be nice to have somewhere like, oh, put open source data here.
Yeah, because what we could think about, and I don't know if this is a terrible idea or not, but is with the GeoSci site is basically just to have a data.geosci.xyz. And then have some sort of template for people to put data somewhere. And we don't even necessarily have to be the ones hosting the data. Like we could ask them, if it's small, you put it on GitHub. If it's large, we'll figure something else out.
It's like, I know the school has their own servers here.
Okay, yeah.
Everything, it just, okay, we'll put a link to the data or something, maybe,
Yeah, because I don't want to become a data repository, but if we, if we could, basically just provide like the landing page of just here's like maybe data license citation, like link license citation, basically a metadata.
Yeah.
Actually, could be interesting.
I think that'd be something that'd be nice to have, just in general. Because they do collect a lot of different data over the same area usually. So it's like, gravity, magnetics, frequency domain EM surveys, time domain EM surveys, electrical resistivity stuff, IP, seismic, like they usually collect everything over the same area. So it'd be kind of nice to have it all in one spot to be able to play around with that. I don't know.
We sort of had that with TKC. We had, well, we had a fair amount of different data types. We didn't have all of them, but we had quite a few.
Yeah.
Yeah, something to stew on. Well, that's great.
Yeah. There are just other random thoughts that I had. I sent a message to Lindsay about this, but I just want to get other people's opinions. So what they do on Conda Forge right now for all of their feedstocks and everything for people to like modify them is their suggested form of this is to fork whatever feedstock it is to your own repository, make changes there, and then push from your repository to the main feedstock. What that does is it only builds things once, right? It only builds things on the pull request side. So whereas with SimPEG right now, like we're pulling and pushing stuff from the SimPEG repository. So every time you push something to a pull request, it gets tested twice, it gets built twice, things like that. So just random thoughts about where people feel about like forking and kind of general pains about people, because it's one of those, like we could recommend people do that at some point or not. I'm just thoughts in the air. Yeah, just to kind of avoid the whole extraneous resources that we don't necessarily need to be using.
One thing I was wondering, well, I'll voice, because I was chatting with Joe with this briefly, is I'm wondering if we can actually configure Travis or Azure to actually not do that dual build. Or potentially only build. I mean, I think the simulation refactor right now is a bit of a unique case because it's a ginormous pull request, whereas hopefully down the future, like pull requests will again be a bit more bite-sized. Yeah. I don't know what's I guess the other thing that I like find just a bit more challenging with forks is like going and updating other people's stuff, is because then you need to like check out their forked branch, which is not super complicated, but it is a complication.
Yeah.
Do other people have thoughts on this? I'd be curious to. Have any of you actually worked with a fork before?
Not really, not really. So one example that I had was somebody actually who are not a SimPEG developer, and they forked, and they made a pull request. And then actually I wasn't sure how to merge that in even into our branch. So what I had to do is I merged that into a separate branch. So I generate because we cannot merge that into master directly. So what I had to do, I generated like a small branch and then merge that in, and then I merged that into a master. Like
was there any reason why you
is that how it's supposed?
There generally shouldn't be any blocks.
It's blocked.
Master. Maybe it might be a setting on the SimPEG repository. But I mean, I merged into other.
Yeah.
I've merged into other master branches before. On other repositories.
Yes, I think that's on the SimPEG setup site, because so that's that was my experience. Like that was my only experience. Like, oh, okay, that's sort of the only way that I could like kind of merge the fork branch into SimPEG master. So it was a multiple steps, which I thought maybe it's better to actually like if you can directly merge, because like once that passed the test, we should just directly merge that into master, maybe. But nothing, not directly related, but
no, it's fine.
somewhat related.
I know I've merged things into other repositories, master branches, and it didn't have to go through that whole roundabout way. So that's why I'm curious. I haven't dug into what the SimPEG settings are for master pulls. like if it's some sort of setting somewhere that has to be pulled in from its own repository.
I guess one other concern that I have, and this is more on the workflow side of things, is I know right now it's not uncommon for folks to actually like create a branch or tell a user basically we want you to be using this branch. Oh, let me just push the update, and like. I mean, so we've done that a bit with the simulation, just as it's kind of evolved, right? Is like John's working on simulation DC, and so he can point all folks that he's working with to that, and they don't have to. All they have to do is a git checkout. Yeah. So.
I mean, I definitely see. Like, I just random thoughts in my head, just thinking about things. Wanted to chat them out. I'm not feeling strongly either way on anything. I'm sure. The only thing is I realize and there's, maybe it's a thing of we limit testing to certain branches, or we limit testing to certain branches, all pull requests or something else. I can look into it some more that way as well, but yeah.
Yeah, and I guess it would reduce the mess of the number of branches we have right now, but we're stuck with that. We need to clean them up. And
I know I've been trying to look through, and there's just so many branches. I'm like, this is crazy.
Yeah.
And there are like 19 pull requests, but there's like hundreds of branches.
Yeah.
Yeah, guilty as charged. I have a bunch in there, but other than being cluttered for the eye, eventually they'll get so far behind that we'll just abandon them.
Yeah.
Pull out what was good in them, and then carry on.
Yeah, and I'm definitely gonna try to go through and find some dead branches and things that have been merged in but weren't deleted, and so on. I've been trying to keep up with that on these simulation pull requests. So once the branches served its purpose, there's no reason to keep it around anymore. So yeah. Another step to move forward is just cleaning up all of the branches.
Yeah.
Gotta trim the tree.
Yes, exactly. We do need to prune the tree.
Pretty little bonsai there.
Yes.
Right now it's more like I don't know, a bush of something, an apple tree.
It's overgrown for sure.
A blackberry bush.
Yeah, exactly. I'll share. Well, Joe, did you have anything else? I'll share a quick update when you're done. Okay. So I pasted a link into the notes there, and I can drop it into Slack or into the chat here. Actually, it's probably simpler right now. I've been trying to just do a bit of sketching around. Here we've got this Jupiter Meets the Earth project, and one of the things that I pitched is actually doing inversions. And when in the proposal pitched MT, because I knew that that was an area where we wanted to invest a bit of effort. But now I think we lucked out that that's actually pretty timely, it sounds like, for Dom and John, and Devin's been keeping a pulse on things. So I just created this doc to be like a bit of brainstorming, a bit of planning, and then down the line we can sort of, divvy up labor and figure out who wants to focus on what pieces and all those sorts of things. But this is basically what I'm roughly planning to pitch to the group here. So if folks have other feedback or other things that you want to prioritize, and in particular also if there's other things that you would like to see in the connections with Jupiter and Jupiter Hub, Jupiter Lab, those are things that are totally in scope with this grant. So I put down a couple of ideas. There's one, Joe Hammond has done some really cool work with basically setting up a Redis server to do data streaming. And what would be really cool with this, with SimPEG, is to actually be writing out like fields objects, or writing even inversion results and things like that to this Redis server. And that actually lets you basically interrogate while the computation is running. So I could be basically watching gradient updates and things like that, which actually would be kind of cool, is to be able to introspect some of the data that we would typically lose, right? We don't keep all of our delta energy. but to actually sort of watch that as the inversion is running would be kind of fun. And so there's the pieces are out there to sort of think about those types of things. So if you have any ideas, just like as you're working, just like, oh, this would be incredibly useful, or wouldn't it be cool if I could actually look at this piece of information throughout the inversion? Or, you know, one of the things that I want to look into, and I think that some of this work has already been started and it might already exist, but is like an object viewer. So that, for example, if we have a simulation object, if somebody can actually just click on like a variable viewer, much like what you would see in like maybe VS Code or something like that, to be able to see like what you can do with it. Yeah, so those are just a couple ideas. But if you guys have others, I would appreciate your thoughts.
So do you need to like label your code to be able to inspect on the fly what's running?
I'm not entirely sure. I mean, because the tab completion doesn't really require any special infrastructure, right? It just introspects the objects. And same thing with docs. As long as your doc string is in there, we can they can grab that automatically.
No,
So
but you're talking about like looking at like processes as they're, you know, let's say you're inside the inversion cycle, you want to spit out a vector. Like this is kind of real time crunching, right?
Yes. So in this case, I think there would need to be a little bit of instrumentation, but hopefully it's actually pretty light. And that's something I need to dig into and actually see how this is functioning with Joe's work. But I imagine that that would be something that like we could create basically a directive for, is basically like inversion watcher or something like that, that can then just watch whatever variables you ask it to.
Yeah, I think to me, what would be the most interesting is that once we get to those big EM problems, we kind of want to know, you know, what are we waiting after? I know, is it doing like factorization? Is it doing which frequencies it's stuck on? That kind of stuff, you know. So we could have like a feedback. Maybe DAS can do this for you, but then if you don't run DAS, we're not going to have it. Yeah, just something that would be interesting to have.
Yeah. So in a sense, it's like basically something like almost watching your task stream in a sense.
Yeah.
Okay.
Because it's kind of annoying, right, when it's spinning, and then you're just like, okay, how much time I have to?
Yeah.
What are you doing? How much time do I have to wait?
Yeah. Yeah, I mean, because I imagine that whatever they did for Dask for that is something that we could probably look into. Yeah.
I guess they're crowing the processors at that point, right? They were saying like, okay, what each processor is currently doing.
Yeah.
So it's not really the code itself; it's more like the hardware.
Mm-hmm.
But, yeah, I don't know if it's possible.
Cool. Yeah, well, I mean, feel free to add to that later on, and then we can maybe even have a bit of a focused MT meeting when things start ramping up.
Yeah, so we're meeting, yeah, as I told you, next Wednesday, right? So, well, now it's going to be a web conference, but yeah, and then probably starting, I'm guessing, the next month. Okay,
excellent. Is there anything that would be constructive to have from sort of the SimPEG side of things, or like, I don't know, if you, I mean, you're welcome to share this document with them if that's useful, or if there's anything else that would be helpful to have prepped. I'm happy to throw some effort at that.
Yeah, if you don't mind, I might not share it, but there's like so many good bullet points in there, that things that we would like to achieve. It's basically all the things that we could work on, right?
Yeah, so, yeah, sure, go for it.
You did a good job there. It's high details enough, not too much details. That's good.
Cool. Okay. Anything else anyone else wants to bring up before we wrap up?
Yeah, I just had one other thought now come across my mind as we were discussing Dask stuff. I'm not sure if you guys had this conversation already when I wasn't here, but if not, I'm going to ask. Is it something that would be better served to have like a side repository where it's like you would say like import SimPEG data with Dask versions of them instead of having it baked into the base repository. You know what I mean? Like a separate module.
Yeah.
That is something to think through. Dom, do you have an initial reaction with that?
Well, I get it. I mean, it's super invasive, right? We're changing the way we're computing things, and it makes the code a lot more complicated. The only concern I would have is that we would have to maintain both. You know, if we do any changes to how things are done.
No, I completely.
Yeah. It's the trade-off.
Yeah, I completely get it. Just kind of a random thought, and I wasn't sure if that conversation had ever happened or
no,
had been brought up or anything. Okay.
No.
So, just something to think about. And
yeah. Thanks for raising it. It's not a bad idea.
Just one of the things is like, oh yeah, it does add a lot, and it's really powerful, right? It's really powerful, but like, okay, well, I mean, situations where it's not needed, or somebody doesn't want to use it, right?
Maybe we just need to code it better so it's more, it's clearer, or I don't know, streamline how it's written right now.
Mm-hmm. I don't know, maybe that also would let you like focus more on the data side of it too, you know? Like, okay, well, I'm not worried about all the SimPEG side and doing stuff. I'm just going to focus on just doing the data part of it. Because I mean, especially with the simulation branch, I feel like that will make it easier to do that kind of things, right? Because all you have to do is like change out a few functions within a simulation, right? It's not that hard to just kind of inject things into a module that's already loaded.
That's a good point, man. That's a good idea. Yeah. So you basically, instead of having those blocks of Dask codes sitting inside the simulation, we would just be putting them outside and bringing them as a module. It's not a bad idea. I'll put it on the back burner.
Yeah, me too. That's a cool one.
Okay, I didn't have any preferences either way. Yeah. No.
Okay,
Okay, see ya.
All right, thanks everyone.
Bye-bye.
Have a good week.
Take care.
Don't touch your face. Don't touch your face. Don't touch your face.
Yeah.